morning. Welcome to SVN3E. This is Wendy Espana, and we are working on lesson 3. We began this lesson in our last class, Common Methods of Sampling and Monitoring the Quality of Soil, Water, and Air. And we were discussing how sampling means to take literally samples and to test them to see if they have any contaminants, pollutions, toxins, anything dangerous to plants and animals. Also to look and see levels of things like oxygen, dissolved oxygen in water. Look at levels of acids and bases, testing the pH of water and soil, and seeing if they're within a range that's acceptable, that animals and plants can survive in. And so we spent quite a bit of time yesterday in our last class talking about that in terms of soil. We went through the little booklets. On page 12 is the start of lesson 3. And we did go through that, and we did go to methods of water testing, measuring water quality, and we did a brief review of that. We're going to go to that in more depth today. Then we went into measuring soil quality. You'll remember that we looked at color and texture, humus content, macroorganisms and earthworm content, pH, which I already explained, temperature, dissolved oxygen. The riparian environment means the environment on the shore of the lake, pond, or river, the presence of aquatic plants, turbidity, which we've gone over quite a bit, looking at if the water has got suspended particles. We know that that's the case if there's a lot of, if it's cloudy. And so that's something that we look at. And then we looked again at the lesson 3 key questions. We're going to come back to those in a few minutes and when we're done towards the end of the lesson 3. But for now, what we're going to do is we're going to go over to the other material that we use, and that's the workbook. So we're going to go over to the workbook that is unit. And for some reason, I don't see the workbook. So just give me a second and I'll go find that for us. I had it all set up when we started, and I can see on here that for whatever reason, I can't seem to find my workbook. So I'm going to just go back over and quickly get that for us, because that's what we really want to be looking at right this minute. Alrighty, here we go. And we'll go. Okay. And we'll find it over here on our. And once we get into the workbook, we're going to go in back what we finished last time. If you recall, we finished the looking at the water sampling and monitoring drinking water is where we're going to get into this time. We looked at depth integrated sampling, and we're going to go heavy into that now. That's one of the methods of testing water. If you recall last time, we finished off by looking at ways to keep our soil sample healthy. And so now we're going to look at ways to, there we go, that's better, found it right here. Ways, we're going to look at water and water testing and how we keep water healthy. Okay, we're all set, here we go. So if we look here, we're going to go to the textbook, page 20. Last class, we ended off looking at the soil samples and all the different qualities of soil that make soil healthy for your plants to be growing in. And now we're going to switch over to another sphere. Remember the 3 spheres, soil, water, and air. So now we're going to switch to water. And we're going to talk about depth integrated sampling. We talked about it very briefly when we were going over the textbook, or not the textbook, the booklet materials. And now we're in the textbook and we're going to look at it in a lot more detail. Okay, So, depth integrated sampling is one of the tests that lets us know if the water, surface water, is healthy. So, we're going to describe the method, and then we'll look at some of the things that how we can test, what we can test in those samples. Okay, the important thing with a depth integrated sampling is that you do not touch the bottom of the river or lake or pond when you're coming near to the bottom, but you don't touch the bottom. You don't want to have any of the soil in there. You want to know the water itself, what it contains. The reason that we call it depth integrated sampling is because we go into the water all the way to the close to the bottom without touching the bottom of the lake, pond, or river. And when we go into there, we collect the sample and then we put a cap and we pull it up. And that way we have a sample of water right from top to bottom of the water. And then we take that and we give it to a lab, or maybe we have our own lab, and they do the tests that we'll talk about in a little bit on the water. Why do we use this fancy depth integrated word? Depth means it's going deep. It's giving us a good deep sample of the water down to almost the bottom. And integrated means it's mixing. When we pull the water up and put the cap on, that that means then that the water sample gets mixed up. That means that we don't know whereabouts in that sample the water came from. And so if we did have concerns, we'd have to go back and do some more testing on that. Okay. Towns and cities use this method to check whether water is safe to use. We use water for drinking, cooking, washing, all of those things. And so this is the method that they use. It's Most people in Ontario get their water from water that's been processed by a town or a city, and those municipalities will do year-round testing. It's mandated. You have to make sure the water you're drinking is tested. And there's three main tests on drinking water, water that comes out of your tap, to make sure it's safe. The three main tests are microbiological testing, chemical testing, and radiological testing. So we're going to look at each of those three tests in a little bit of detail. So microbiological testing. Okay, what does that mean? These are bacteria, perhaps. It could be other organisms, mostly bacteria, that they're testing for. And we call the microorganisms that they're testing for in drinking water the total coliform count. And we've talked about that before. We've heard that word before. Total coliform count. And the microorganisms themselves are called total coliform bacteria. One example of that would be E. coli bacteria. And this is what we're testing for in water. Now, the total coliform bacteria is not always harmful, but if they're present in drinking water, it could mean that the water is contaminated. So they are, even if they're not the harmful types, it could be a sign that we are dealing with a bacteria that it could be dangerous. This has unfortunately happened in our different water supplies that people have actually had some issues. There was a terrible crisis many years ago, I think in 2000, I believe, in Walkerton, Ontario, a small town in southern Ontario, and E. coli got into their water supply. And the form of E. coli was a dangerous one because, again, just like everything else, E. coli could be helpful too. E. coli is not always deadly, but in this particular case, a deadly form of E. coli got into their water supply and ended up causing six, I think six, seven, maybe seven people to actually die, and hundreds become severely ill. And so, anytime E. coli is found in a water supply, it it means there's an issue. And so if you have healthy water, it will not have any E. coli. So the minute that E. coli appears in your sample of water, you know that there's an issue, and the water needs to be treated immediately. We're going to talk in just a couple of minutes about what happens if it is contaminated. Okay, so that is looking at microbacteria. So now we're going to look at the second group that gets tested, the second type of testing, and that's chemical testing. So, two chemicals that you do not want in your drinking water are nitrates and lead. Okay, nitrates are naturally found in water. They're part of the nitrogen cycle, and we've talked about those earlier. However, they can also come from fertilizers and sewage. So you want to make sure that the nitrates that are in the water are not coming from a chemical fertilizer sewage. And so you'd want to test, you'd want to go to the site, you'd want to test where the water is coming in. Remember, it could be in surface water, which is surface on top of the ground, or it could be in your groundwater, underground in the groundwater. And so you want to test for that to see where is it coming from and how much. Remember, there's always a range. And in some cases, I shouldn't say that. There is no range for E. coli, for instance. E. coli, it has to have zero. You do not want any E. coli in your water. However, some of these other things that do naturally occur in the environment, you want to see what the levels are. Lead is another one that can enter water, and you do not want lead in your water. Again, there might be a natural occurring source in the environment, but it's usually from old pipes and old plumbing. Many years ago, they used to use lead for doing plumbing. They don't anymore, though. That is gone as they've realized that lead can cause serious health issues. So they would test for those to make sure that the levels are low or none at all. And if they do have any, they'd have to go and do some work on figuring out what the cause is. Okay, there's also radiological testing. So they're testing for if there's anything that is giving off radiation. There's some natural, especially minerals, rocks that do naturally give off radiation. And so you'd want to be super careful at the level. The level. Low levels of, for instance, uranium are pretty normal in rock soil and, of course, in the water that is sitting on top of the rocks and soil. But you want to make sure that it's very low and that it's within a range that is safe for drinking water. There's other things that we can test in water. We've talked about some of these already. Turbidity is the one we've discussed before. That's when the water could appear cloudy if it has too much suspended matter, particles in the water. The cloudier the water, the higher the turbidity. So you want to be careful about that. And you'd want to make sure the water has good quality of color, and I guess you'd want it to be colorless. You don't want it to have a color. You would want it to have no odor. You'd want it to be odorless. And the taste, you wouldn't want any taste associated with the water. So those are things that you could also check. If you live in an area where there's well water, remember, well water is water that's coming from the ground. Um, One of the things that can happen in that type of water is the water can have dissolved calcium or magnesium. Hard water is not a health concern, but it can do a lot of damage to things like any of your appliances that use water. It can get build up calcium or magnesium and can really do a lot of damage. To counteract that, people use what's called salt. Um, it's not salt like you use on at dinner time, but they're big, kind of look like big rocks. You get them in big bags, and you dump it into something called your water softener, and it will help get rid of the calcium or magnesium. Sometimes iron's another thing you can have from water that's coming uh, from a well, and it makes sure that those are not going to be an issue uh, in in your system and damage all your appliances. Also, it's awful to people who have had well water know if it's not softened. Sometimes it's when you shower in it, your hair gets really kind of like feels hard almost, and your skin can get irritated by it. So there's all sorts of things from hard water. It's not toxic. It's not dangerous. However, it's just irritating. So that's an easy fix. You can test water to see how hard it is, to see the levels of calcium and magnesium in it as well. If your water is contaminated, if we do find something when we do this testing, then we have to solve the problem. Um, if you can take water and boil it, and that will get rid of your contamination, and then you're safely able to drink it. It's called a boil watery advisory. And so, if you're under a boil watery advisory, it means that you have to boil your water before you're able to use it for drinking water or maybe brushing your teeth or anything like that. You can use it for showers. Sometimes people use it for cooking. I'm pretty good about that, but you have to be careful. So, you could shower in it, you could bath in it. However, you have to just be careful that you don't get water in your mouth because that's just like drinking it and can cause a lot of issues. There's also something called the Drinking Water Advisory. And that means that you can't get rid of the contaminants by boiling in the water, that there's an issue that you need instead to actually not drink the water at all. And so, what you have to do in that case is you have to get another source of drinking water. For some of you listening, maybe where you are, your community has had boil water advisory or it's had a drinking water advisory. Um, some communities have a store or a couple of stores where you can go and buy bottled water, um, and until the problem is fixed. Okay, we've got our check your understanding questions on page 22. Last class, we went over the check your understanding questions on page 19. So today we're going to talk a little bit about the check your understanding questions at the bottom of page 22 in the workbook. You'll see there that the first question is, how is a water sample collected using the depth integrated sampling process? You'll notice that there's not a big space. However, that question, if you look in the booklet and it says page 22, question 1, it's worth 3 marks. It's very easy to come up with three steps for that process, and we've talked about it. There's a picture on the or a diagram on the previous page, gives a really good explanation of how we use depth integrated sampling for water. The question 2 is, when drinking water is tested, what is a microbiological test sampling for? And if you'll remember, there was a very important one that they test for. um, there's two actually, um, that you can put down, and it's worth 1 mark. And question 3, if water is turbid, what would it look like in a clear gas? And we've talked about turbidity quite a bit. You can go back and look above right there, and it gives you a really good explanation of what turbidity is and what turbid water looks like. Okay, we're now going to move into air. So we haven't really talked about sampling air, monitoring air, um, but it is extremely important. We've talked a lot about how in the summer we had a lot of smoke in this area, and that the smoke caused a lot of issues, health issues, being able to be outside and enjoying the outside because of the air quality. And so that's what we're going to talk about. There's lots of different ways that we measure air quality. We're going to start by talking about stack sampling. So, one of the ways that air gets polluted is from burning fossil fuels, coal in some areas. I'm not even sure if we're allowed to burn coal in Canada or in Ontario anymore, but they certainly can in the United States, where sometimes with wind it can blow into Canada. And so these burning fossil fuels creates a lot of contaminants, puts a lot of gases in the air that contain chemicals. Um, we do have pulp and paper mills in Canada, and we have one I've talked about earlier in Dryden, a paper mill. There's also one in Thunder Bay. They have now a lot of guidelines about levels of emissions that they're allowed to put in the air. This wasn't always the case. Many years ago, there was a lot of pollution produced by mills in Canada, and this pollution led to having dangerous chemicals go into the water and soil near, and in particular in Dryden, it would go into the river in Dryden and then flow into the lakes, and it would carry chemicals such as sulfur, mercury, carbon. Mercury, in particular, was a real issue and caused people living in nearby communities who did a lot of hunting and fishing and ate a lot of the fish coming out of the river that was contaminated to get diseases caused by the chemicals. Mercury, in particular, caused a lot of neurological diseases, affected the brain, and these people were very severely affected and very ill from the air coming, the gas being produced by the mill. It's now been cleaned up, hopefully, continues to this day to be clean. The mill is still there and running. However, it's got a lot of safety protocols now. Okay, you have to sample the gases coming out of the mill through what's called stack sampling. Those in the picture show smokestacks. That's the how smoke leaves the factory, the mill, whatever company that we're looking at, and they have to sample the gases and monitor them as well. Um, so they use something called stack sampling. It's equipment that as the steam is coming out of the smokestack, there's probes, and the probes are attached to tubes called sample lines. You can see in figure 1.26 there that they have sample lines on the side of the um, of the smokestack, and they run up the side, and they check what's happening. They take samples from inside the stack of the air that's coming out. Um, they can also remove some of the gas and then take it to a detection or analysis station, and they can test to see what is being produced by the factory. Um, Another thing that we monitor, remember we talked about earlier, is smog. So, smog was the ground level ozone, very toxic. Remember, ozone's very useful. It keeps the ultraviolet rays that from coming in to the Earth's atmosphere. And so, as a result, we don't have damage to our skin and from the ultraviolet rays. However, we talked about how over Australia there's a hole in the ozone layer there, and that people are suffering from skin cancer, and so they're very careful over there to make sure you put on a protector against the sun when you're there. They have at the beach, they have sprays. They're free. You just go stand in line, you get sprayed while you're at the beach, and it keeps the ultraviolet rays from reaching you. However, when ozone now starts to accumulate at the closer to the surface of the earth, it becomes something called smog. And one of the main ingredients of smog is the fine particulate matter. And that is things like little particles that are in liquid in the air. Aerosol, smoke, dust, these are formed from chemical reactions from, say, a car or a factory burning the fossil fuels. And what they do is they measure the particulate matter in the air, and they do not want people breathing in these particles. They're not healthy. If they're being produced by the factory, there's probably chemicals like we already talked about, uh, sulfur, mercury, and carbon in those, and you do not want to be breathing those in. They can cause serious health problems. So, monitoring the air over time is also extremely uh, important, especially if you have smog. This can be really true in some of the countries overseas, maybe, or in another part of the planet where they have a lot of industry, a lot of factories, a lot of production of all the things that we buy. We're the consumers. We're the ones who go and buy the products in Walmart or Giant Tiger or wherever we go. And so that's how they're made, though they're made in other countries. Um, we have something you can look up. It's called the Air Quality Index, and it tells you about levels of smog in the area. They also talk about any air quality issues. So they're a measure of six key air pollutants, including ozone and the particulates in the atmosphere. And so, on if you go to a weather report, they will have the air quality index reported there, and they let you know every day, all year long, what the quality of the air is in your particular area. Um, if it's poor air quality, if it's really bad, for instance, the smoke, they will send an alert. This summer, when the smoke got really bad, they sent an alert out saying that, you should stay away. If you can not drive, mow your lawn, activities that are going to produce more particulates in the air, and as well to remain indoors and not do any strenuous activities because you're breathing in more and more of these smog or other particles, the smoke we had. And so they will send out an alert. And if they have an alert, you should, and I mean, even if there is an alert, if you could follow some of the rules for keeping down air pollution. For instance, taking public transportation or walking if you're able to instead of driving. Sometimes that's difficult, especially, say, in a little town like ours where we don't have public transportation. However, if you can ride share, drive with somebody so there's only one vehicle producing any sort of air quality issues, that would be better. Use less energy in your homes. Energy has to come from somewhere. Our electricity has to come from somewhere. And in some areas, keeping the energy down in your homes means that not as much electricity has to be produced. Not using oil-based paints and solvents. They can be very toxic to the air. And again, I already mentioned not mowing the lawn when your air quality is poor, not going outside and doing strenuous activity when the air quality is poor. Okay, here is another really good chart. It goes over what you're looking at in terms of ranges. And I like that. It gives us an idea of when we should be concerned. So we have the air quality index. Here is a chart showing the ozone, the ground level ozone. Remember, ozone in the atmosphere is healthy, natural, keeps out the UV rays from reaching Earth, which is a really good thing, keeps us from developing diseases like skin cancer. However, once it comes to ground level, it can have lots of effects, and we're going to talk about that in a minute. We also have the fine particulate matter. That's particles in the air. So this would have been smoke this summer in the air was particulate matter. And so they're giving you the different index ratings and then what it means. So if the air quality index is very, very low, that's good. That's what you want. You want it to be low. 0 to 15 is very good. It means there's no health effects, there's no smog. And if you're sensitive and it's above 0 to, say you have asthma or heart problems, you want to always be cautious, but you might want to be a little cautious. If there's a little bit of fine particulate matter, so a little bit of smoke this summer, I still went walking. However, I was cautious. I didn't overexert myself. 16 to 31, if the index is 16 to 31, it's still a good air quality. There's no health effects again from the ozone, but you again might just want to be careful when there's particulates in the atmosphere about exercising. You want to be careful that you're using caution. If you have any any people that are sensitive, people with asthma, small children, babies, older people who might have some breathing issues, and anybody with heart problems, anybody that's sensitive, you might again want to be very careful. Okay, the air quality index goes up from to 32 to 49. The category now is moderate, and now if you're sensitive and we've talked about who those people are, you might start getting irritation when you're doing a strenuous exercise. If you have a heart or lung disorder, then you have to be very careful because you're now at risk. And plant life is now at risk to getting damaged, especially if it's a sensitive plant. We know that some plant life is very sensitive. We talked about that with the pH levels, that they can affect if they're sensitive plants. And so you have to be very sensitive now. And people who have respiratory diseases, that means breathing diseases. So those would people with asthma, COPD, bronchitis, those types of breathing problems, they are now at risk. And so you'd want to be very careful. So at this stage, I have asthma. I like to walk, especially in the summer. However, if the air quality was 32 to 49, I might now decide that I'm not going to do a long walk. Maybe I could do a shorter walk, get outside, get a little bit of fresh air, but not too much. Okay, if the air quality index is 50 to 99, that means now we're into the poor category. That means that we're starting to build higher ozone at the ground level. And you could actually now start to get lung damage if you're very active. If you do too much physical activity, you're now going to actually cause some damage. You again are at great risk of having issues develop, and some plants, not just the sensitive ones now, could get damaged. What is the issue with smog? Is that you block out the sun. You block out the sun and the plants are not able to receive sunlight and undergo photosynthesis. That's what's causing the damage. People with respiratory diseases now, the fine particular matter at this level says that people with respiratory diseases should limit any activity that's prolonged. That means that a long walk, a long hike, going maybe for a kayak trip, those types of things, you should be very careful with a long time and limit your exposure. The general population is also at risk, so you want to be careful even if you do not have any respiratory issues, you're not in the sensitive category, you do want to be careful. And so this summer, when it was very smoky, this was an issue. For even people that didn't have any problems, it was important that they were careful not to develop any problems. If the category is 100 and over, that's very poor. That means that you should not be outdoors, even doing light exercise. You shouldn't be outdoors. It's not healthy at all. They sensitive people or people with no sensitivities should not be going outside and doing any sort, even light activity. Okay, plants damaged, and just in general, it's not good. All right, so I'm looking up the air quality in for our area, for Sioux Lookout area, and seeing what our air quality index is at the moment. And it says it shows a summary of the recent values for Canadian cities. Okay, so it's only doing it for bigger cities. So let me see if, oh, yeah, and I don't even think we're going to be able to get it for Thunder Bay, but let's give it a try and see if we can get Thunder Bay Air Quality Index and see if. No, it's not letting. I don't think it's gonna. It seems to just give us for the bigger cities, which is too bad because Thunder Bay. Here we go. Let's see what its was. Air quality index for Thunder Bay. It's right in the Environment Canada. You go on Environment Canada, and you'll be able to see it right there. Every day it'll have. And I'm just going into Thunder Bay to see it's currently. Okay, so we're going to go to the air quality for some of the other cities, and we'll see what they're at because this one here is not letting us go to. Okay, so let's go see. So we would expect somewhere like Calgary not to be too bad. Let's have a look. Its value is 4, so that's moderate according to this. So that index and this one's slightly different. Calgary is probably being affected by smoke, which is why and Saskatoon, it's got moderate risk in Saskatoon as well. That's probably smoke. Prince George is a high risk its smoke. Its air quality is very poor for smoke. So they're still experiencing probably forest fires. Oh yes, here's the air quality health index for this one. It goes from 1 to 10. So instead of going from 0 to 100, this one here on the Environment Canada goes from 1 to 10. And so 4 would be 40 on here, which does match. It is moderate. Yeah. And 6 would be 60 on here, which is poor. Yeah, that's what it's saying too. If we go to a place like Toronto, it's 40 on our scale, and so it's moderate. Toronto often does because it experiences it's got a huge population. There's all sorts of vehicles, there's all sorts of industry there. So Toronto's very high. Fort Smith's extremely high. Its air quality index, according to this, is 7. And again, it might be due to forest fires. I'm not sure what. Let's just have a quick look. It's going up to 7 tonight, which is quite high. So that could be the issue there, is that there's smoke coming in the north of Alberta and Saskatchewan, maybe still from forest fires. So you can just look online to Environment Canada and just go to, now it doesn't have all places. I did try Sioux Lookout and it did not let me look up what Sioux Lookout air quality was because we're too little, but the bigger locations, it'll definitely have it. Except for smoke, Sioux Lookout has very little to no industry, and so it would not have that issue. We are a very small population. We're mostly of trees, rocks, and water. So we would not have the issues that the bigger cities would have. We wouldn't have the issues with smog and particulate matter, etc., in this area. So that's a nice little thing of living in an area like this, a small town in the bush, that you're not going to have as much issues. Okay, if we go down here, we can see next on page 27, we're on the review questions. Now, we before we do the review questions, I just want to show you that we could also look on on a page. Come over here. There we go. On the pages from the booklet that show the key questions. So you can see lesson 3 key questions there are on page 16, and they say the questions are in the textbook, page 18 to page 27. Lesson 3 key questions are worth 23 marks. These are the questions you're going to hand in. You need to get out lined paper, or you can also use your laptop, your computer, and you can type them out. You don't need to write the question first. You can just write the answer. However, make really clear what questions they are. So you would write at the top of your page, lesson 3 key questions. And then when you're starting the questions, and if your first questions are page 19, you check your understanding. We already went over those ones. You would write page 19, question number 1. Also at the top of every page that you're doing questions, you should put in your name. Put your name at the top of each page, and then page number and question number. This page 16 from the booklet also gives you how much each question is worth. So you'll see we went over page 19 and page 22, and remember I said for questions 3 and on page 22, question 1, there were 3 marks. When you see that, you want to make sure you come up with 3 points for me to be able to give you the 3 marks you need for that. Okay, we're going to go back to the textbook now, and we're going to look at some of the review questions. These are on page 27 of the textbook. So at the top of the page, you're going to say 1.3 review questions, page 27, and the first one that we got from the list that we just saw. And I'm sorry, I'm not sharing the right page. Let me go over and make sure I got the right page. Okay, there we go. Sorry about that. There we go. Now we have page 27 on the screen, and we're going to go through these. The first question says, it goes back to our farmer, and he's gotten his core sample report back, and the pH of the soil is 5.2. So the first thing you have to ask yourself is that high or is that low? Like, what is that? What does it mean? What would a pH of 5.2 mean? That's your first thing you're going to talk about. And then what do you do then if it is a problem? If it's not a problem, then that's okay. However, if it is a problem, and a soil pH of 5.2 is a problem, right? We talked about the range of healthy soil, and we know that less than 5.6 is an issue. It means that that soil has now become acidic. And it talked in the textbook about what we do when we have acidic soil. So go back and have a look at what it tells you to do when the pH is below 5.6. Okay, question number 2. A farmer receives a soil quality report and he notes the following information. He has 40 worms per shovelful. The soil crumbles easily. The pH is between 7.4 and 7.6, and it's medium colored soil. Is that good or not? What do you think? What would you tell him? And then uh what would you say that he should do? Leave it, it's good. Maybe do some of the methods we talked about to improve that. Have a look at those results. Go back to where we had that nice chart. We have a good chart in our textbook that shows us what all those different tests, what the results tell us, and you'll be able to say what you think and why. Always more importantly to put why. Okay, that's worth 1 mark for each of those 2 questions. Number 3, list 2 factors that contribute to low quality agricultural soils. And we talked about that. There's 2 main reasons why soil gets low quality. And we've talked about those right from the first night. So you should be able to come up with 2 different reasons why we get low quality soil. Number 4 is how do cover crops help improve soil quality? So if you're not sure about that, go back to the information on soil testing, and you want to look at what was it cover crops were helping with. And so that'll give you your information on how to improve that. Number 5, when a water sample is collected using the depth integrated sampling process, why is this sample called integrated? Remember, we talked about what integrated means, and we talked about what this process does to the water. And so you want to explain why it's called integrated. That's also worth 1 mark. Number 6, name 2 chemicals that can be detected in drinking water when a chemical test is done on it. So remember, there's 2 chemicals. One is naturally occurring, but you want to keep the levels down. And there's another one that you cannot have in drinking water. It will cause illness. So go back and have a look at that. Question 7 is not listed in the booklet. You do not have to do it. So do not do question 7. You can go right to question 8. Question 8 is many chemicals released into the air are colorless and they cannot be observed. What method of sampling is used to detect these chemicals? Okay, so we talked about how chemicals can be released from vehicles burning fossil fuels, factories. They can have chemicals. And what do we use there's a special method they used that for smoke and gases coming out of factories. And how do we then go about testing those using that method? Okay, describe that method. So that's worth 2 marks because you have to not only talk about what you're testing, but how you're testing. Number 9 is why would people with asthma and other respiratory problems have to wear a breathing mask or stay inside if there was an increase in fine particulate matter in the atmosphere? So, what you want to do there is talk about what the danger is. What is dangerous about fine particulate matter? Fine particulate matter, and why is that particularly bad for people with asthma and respiratory problems? Question 10 is not listed in the booklet to be done. You do not have to do it. Instead, you're going to go to question 11, and it says an air quality index of 120 has been reported. So you want to go back and have a look at, first of all, what does an air quality index of 120 mean? And what can you do that day that would help not to add to the smog problem? Okay, that could help actually reduce smog. A lot of times we talk a lot about things that we do to create pollution, to create smog, to cause problems. But people also, a huge part of this course is that we want to look at what we can do to not cause more harm and to actually reduce the harm we're causing. And that's a good intro to that. Alrighty, we will be back next week and we're going to look at lesson 4 next class. Thank you so much for joining me, and that is it for today.